Dear audience, we are very happy and delightful to be here and to have the chance to present you with Rafael AI Enhanced Combat Suite, basically and frankly for the first time where we are presenting this new concept. Here with me is my friend Golan Ben-Ghiat from the Multidimensional Combat Directorate, and myself, Ehud Nir. I'm coming from the Land Maneuver System Directorate. We are both coming from the Land and Naval Division in Rafael. And as mentioned, we are happy to present you with the NGCV suite, which is the Rafael AI Enhanced Combat Suite. And let's start. Pact for superiority, and we will explain. First, I would like to start. I think most of you are quite familiar with our legendary system, which we are offering day by day to the land arena. So we can start from our Samson family, with our RCWS family. We have our well-known Spike missile family with its new younger brother, the Firefly, the loitering munition. Of course, our well-known Trophy APS, basically the only combat-proven system in service more than 10 years. We are offering our battle management capabilities, our add-on armor solutions, of course, our BNet communication, etc., etc. But I will touch, in a really brief, because we are not here to focus on the systems. So if mentioning the Trophy, you can see here just some of the platforms, well-known platforms that the Trophy APS is already in place and integrated on all the IDF combat vehicles chosen by the Americans for the M1 Abrams, chosen with the Germans, for example, for the Leopard, and UK now coming into our family, etc., etc. On the other hand, we have our Samson family. More than 5,000 systems deployed around the world. Again, a combat-proven family of RCWS. You can see here just some examples of our vehicle-mounted Spike missile on just a bite of samples of the different platforms already installed, whether it's on turret or on the platform itself. And we will also explain a little bit down the road about our Firefly. But again, we are not here to focus on systems. What we would like to emphasize and present you here today is the concept of our holistic open architecture, which we call the NGCVS, the Next Generation Combat Vehicle Suite, which basically takes from system to RI. You can see here some of the system from Rafael that we have mentioned. Common vehicle, common platform will also contain with many more systems, sensors, shooters, sight system, driver display, etc., etc., as presented here. And we would like today to sketch the concept that we are presenting, which bring them all together to one symphony. And from here, I would like to go to you, Golan, and maybe start with the focus explanation on the core of the system, the battle management system that we are presenting today as package of suite. Golan?
Thank you, Udi. So after you saw all those incredible and world-famous legacy systems that Udi just presented you, I would like to show you and present you how we optimize those capabilities and maximize the interoperability. The future platform is going to be equipped with a lot of onboard sensors and effectors. All those means going to provide a lot of information to the crew inside the vehicle. We understand in Rafael that we need to manage this data and the solution itself, and therefore we create a small brain in the size of 3U to contain all this information and to control all the package, all the suite of things that we just propose here.
Okay, so again, we are going and discussing what we are saying, that the whole is greater than the sum of the parts. And what we are referring to is, first of all, this combat suite that we are discussing dramatically increase the lethality and the survivability capabilities. We are talking about unbeatable situational awareness capabilities, and Golan will explain about it down the road.
Yeah, of course. And also we can say that it's immune to GPS-denied environment, and that's the beauty of that system.
Okay, we are talking about holistic modular computing core. We are proposing a computing core in that combat suite that takes the outputs from the different system and basically improve those outputs to much better, efficient overall solution. We are discussing about dramatically a much faster response time at a much fast rates. We will explain how we reduce the fighter cognitive burden, and not less important, we are talking about much simple and cost-effective integration from one company under one roof that can give you a holistic solution specifically suited to your requirement, to the end user requirement. And we will go from here and basically explain the core, the heart of the system. And Golan, please do.
Thank you, Udi. So we start with the open architecture, modular hardware, and multiply capabilities that all together come in one hardware we call the brain, which I mentioned before. We have 4 main capabilities here. The first one will be the situation awareness, combat AI, artificial intelligence, which we are managing the entire process and the data only inside the platform. The second will be the drones and UGCV, where we actually have the control and we enhance our situation awareness and strike capabilities beyond line of sight. The third will be the FireWeaver, which connect the platform to the entire maneuvering forces. We create a fire network that all the platforms and the other sites in the battle can actually connect with each other and change information, data, and targeting. And the fourth is the enabler, which is the BNet SDR. It's the radio communication that allowing us to control all those capabilities.
So this is the core, this is the heart of the suite that we are offering, and you will also explain how we first focus on the tactical level, on the platform itself, and then how we take it to the multidimensional, how we influence, how we make the multidimensional connectivity between the platform much, much more efficient.
Correct. That's what we're going to see here today with this presentation. So we start with the situation awareness and the artificial intelligence. So as I mentioned before, as you can see here, it's a small brain that contains 2 main core capabilities, the situation awareness and the combat AI. Those 2 main core capabilities provide the crew, the platform crew, with the autonomous mission support. The autonomous mission support can manage and fully utilize the potential of all integrated systems and enable a wide range of autonomous capabilities, as you can see here. The system autonomy level can be defined by the crew at any moment, and thanks to its open architecture, the system can incorporate and integrate with any existing and future platforms, sensors, and effectors. Let's start first with the situation awareness capabilities. We all know, aware that the situation awareness for a combat vehicle crew sitting inside the vehicle is very limited. Therefore, they are very much dependent on the technology to provide them with the situation awareness. One of Rafael's main goals is to enable the crew to perform any kind of tasks under closed hatches while remaining safe. To achieve this goal, the situation awareness of any combat vehicle crew must be in a very high level. And therefore, using Rafael computer vision technology allowing us to increase the situation awareness for any combat vehicle crew dramatically while using existing onboard sensors and other external sources device. A unique algorithm gather and fuse the data that received from multiplying onboard sensors and other external sources such as FireWeaver, which we'll discuss later. Together it presents the crew with the comprehensive augmented symbols reality, create a common visual language, as you can see here in that screen, and provide the real-time understanding and the complete battlefield picture for the crew. And how that's actually work. So you are an infantry soldier holding an optic device and you are viewing the city. You find the target in a window in one of those buildings. Now, the infantry soldier informed the command about the target and the tank was decided to shoot it down. What you can see here is the tank view, the shooter view. Now, before I'll show you where is the target, imagine to what lengths you need to go as a sensor to explain where is the target. And that's one of the major issues with the infantry and the maneuvering forces. To switch target between each other, it's quite a mess. So what we decided to do in Rafael is, first of all, to use the computer vision technology and to present the target on the screen, on the shooter screen.
As augmented reality.
Yeah, using augmented reality that actually indicate that this is your target. In addition, we are adding the relevant information and the situation awareness for the relevant platform. And by the way, it's much more accurate than a GPS as we are using the 3D model and computer vision technology, which is also immune from a GPS-denied environment. And that's one of our strongest concepts. Let's see how it works in reality. So here you can see a live demo for the IDF where the sensor looking on the village where they're going to attack in no time. And you can see all the augmented reality symbols that present on the screen while the sensor is moving. So what I would like to show you here is that kicking and it's working, it's not a concept.
And everything is being done on a real-time pace.
Real-time based. And that also creates the common visual language, it's allowing us to speak and to understand exactly what you're talking about. Another capability, a major one, a significant extensions to the situation awareness aspect is the ATR, where the system able to automatically identify potential threats and targets and alert the crew on their presence, and also allowing him to understand very easy if it's a legit target to open fire on. The ATR solution gets input from any variety of sensors on board. This data will be transferred using Rafael AI to detect, recognize, and identify the potential threats and targets, such as human, weapon systems, and vehicles. The ATR, what it's actually doing is analyze the sensor feeds in real time, and then alert the crew, as I said, on the presence of potential threats and targets, and even bring automatically the sights to the target, and therefore save a lot of time and leave only the decision if to open fire or not to the operator. So yes, very important to say, the men stay in the loop, so it's not automatically open fire.
Okay.
And let's see how it works. So here it's a live demo where the ATR solution identified the potential threats as a weapon AK-47 and suggest to open fire. Operator understand, open fire. Next step, it will be the vehicle that be defined as an enemy vehicle, and then the operator start to open fire.
Well, this is another subsystem, another sub-capability developed in Rafael to better improve our battle management and the core that we are discussing, that combining the inputs from the overall combat suite.
Correct. It's contribute to the management, and we would like to make it easy for the crew, okay. And that's what make it very easy.
Okay.
So that was the situation awareness. To complete the solution, we're adding the combat AI, where we have the pattern mission planning execution, where the system is calculate the best route for the vehicle to drive on. We have the automatic weapon selection, where the system can calculate the best shooter against the target using many criteria. Can be line of sight, matching the warhead to the type of target, feasibility of success, etc. Autonomous scanning. The system also can perform scanning all the surrounding of the platform and also to concentrate on suspicious area during the maneuvering. Let's see how it works. So here you can see the easy operation for task allocation between the crew and the system. The crew can decide to allocate much more tasks to the system operation or to override the system and to take more tasks to his own hands. In that way, we are able to provide the team something very precious, is a tactical focus. The tactical focus they so need when they are very tired and actually they need to concentrate on the attack. So that is a great example for one of our strongest capability, the path and route planning. where we demonstrate it in live to the IDF. The system perform calculation the best route for the vehicle to drive on according many criteria, terrain, intelligence, etc.
And also influences by the inputs coming from the different sensor and system on top of the vehicle. APS, RCWS, all are influencing, and another good example of how the core of the system is basically working.
Correct. So it gets input from any variety of those sensors. The system calculates in a real time. That means that every second calculation is made for the entire world state. And let's see a short movie where you can see the planned route, which is at the moment in green. Suddenly there is a threat that appears, and the system immediately will change the route, and it's live, it's actually happening. It changed the route in order that the platform will not get hidden. In that way, we leave the teams the freedom to do other tasks while the system actually taking care of them.
Okay, another unique capabilities developed in-house.
So now let's move to the drones and UGCV, where we actually extending the situation awareness capabilities and the strike capabilities beyond line of sight.
And this is our Firefly, as I mentioned before, our unique loitering munition adopted by IDF.
Correct. Transmitting live video to the operator inside the vehicle will actually open for them a new way for beyond line of sight capabilities, as I said. And there is no something that can actually surprise them. They can see everything.
An interesting example of both sensor and a shooter from the sky.
Exactly. So we are using here the lethality and situation awareness on the same on that drone.
Right.
Now we are moving to the Fireweaver, when we actually connect the platform to the entire maneuvering forces.
So from tactical to multidimensional.
Correct. And that's what we are doing by Fireweaver. Fireweaver is actually, it's a weapon system. It's not a BMS. Fireweaver is a revolutionary network combat system. It connects all sensors and shooter over a tactical data link, vastly reducing the closure time of the sensor to shooter loop. Fireweaver determines in real time who can see a marked target, who is best equipped, armed, and positioned tactically to engage. And all this takes place without the need for radio voice trafficking or BMS messaging. Fireweaver provides highly sophisticated fire network of unequal speed and lethality, multiplying force capacity by enabling more precision engagement of more targets in much less time. In that way, we are improving the combat ratio and the tactical speed.
And also that is being adopted by IDF.
Correct. Already been live tests. The contract been signed. We just need to deliver it. So how it works? So if you remember, I mentioned before the augmentation and the computer vision technology. Here it's exactly the same. We have the sensor view and the shooter view. Both of them look on the same target from different angle and different perspective. The Fireweaver using computer vision allowing the network forces with the common geographic accurate visual language from their own perspective. What I see, you can see from your own perspective. In that way, there is no confusion. We can close the sensor to shooter loop very, very fast. And of course, we're using augmentation as a common visual language. One more things to say here is that the elements in the battlefield can share in a real time the target and information in seconds. And that's the beauty of that, which is different than a BMS. And BMS is up there in the command. Here we are talking about tactical tempos, that's it. And that's the answer for the speed.
So you can have many shooters or many sensors on the platform. The idea is to connect them well, to make the outputs from those sensors or shooter most efficient for the lethality and the activity of the vehicle.
Correct. We all know that the fighting vehicles crew, or actually the infantry and the maneuvering forces, when they need a fire support, they need it here and now. And that's the only system that can provide them the fire here and now.
Real time.
Real time.
Okay.
So this is a great example of one of our live demo in Europe, where we integrate to one of our potential customers. Here you can see the augmento, the sensor, find the target, classify it as a building, and disseminate it to the system. Here you can see the target appear in the system. and the system calculates the best shooter, which is the weapon system. The shooter approves the firing, and that's it. Launched, and the fire cycle is ended.
Supreme efficiency in combat management.
Correct. Now we can see the same thing with many-to-many. The capability of the system, of course, is in parallel, many sensors and shooters in the same time. Here you see the footage in the video from two different sensors in parallel, classify the target, first target, second target. The system has some problem with one of the targets here because there is a violation of the rules of engagement. So the commander have to intervene here and to approve the fire request, which he just did. And again, as you saw, all the sensors and shooters been selected, and that's it. So Udi, I think maybe that's the time to summarize all these capabilities.
Well, I truly hope that we managed to emphasize the essence of the NGCVS that we are presenting here. We are discussing about an open architecture, a holistic concept that can be adapted to any kind of platform. We can offer you the different capabilities and system today. Of course, it is suited to the requirement of every OEM and user. And you can, not less important, the idea of adding potential growth, potential new sensor, new system in the future in a quite of an easy manner. So an open architecture, modular, adaptable, with growth potential on one hand. As we mentioned, force multiplier, which optimize the capabilities of each of the system by itself and as a symphony into a one computer, which is the heart of the NGCVS, the heart of the combat suite that we are presenting. And by getting it from one supplier, under roof, one-stop shop, with, which allow you as the OEM, as a user, much simpler, more efficient and cost-effective integration either to the system today and to the future system, I'm sure that it can be highly understood and highly appreciated, the idea of having a simple, efficient and cost-effective integration.
Udi, I think we should also mention that we are in top priority. We put the lives of the soldier and the crews, as I said, top priority. The system and the solution itself provide the real-time or the needs to increase lethality, survivability, and situation awareness, which each one of them connect and enhance the other one. And I think we're doing it very much in that solution, with that suite.
Golan, thank you.
Thank you very much. It was a pleasure.
And of course, thank you, audience, for your time. It was our honor. And we are, of course, here for any further questions. Thank you.